Hello, in this video we will study phase field fracture modeling in Abaqus using a UMAT based implementation. Phase field methods provide a powerful framework for simulating crack initiation and crack propagation without predefined crack path or remeshing. As you can see in this video, crack is initiating and propagating naturally without requirement for predefined crack. After watching this video, you will understand the physical theory behind phase field fracture, the numerical solution strategy, the overall Abaqus workflow, and how the results are validated against published reference studies. Also, you will have access to Abaqus phase field tutorials and custom phase field project support. Before editing, let's ask this question: why phase field fracture? Classical fracture modeling approaches in Abaqus typically rely on predefined crack path or remeshing. For example, in this image, if we want to predict the experiments, we need to define predefined crack and use finer mesh at crack tips, and due to this finer mesh we need a remeshing rule, and our results will be strongly mesh dependent. And also we will have limitation in crack branching since crack moves almost straight in classical fracture models. These will lead to unreliable predictions, high modeling efforts, and poor robustness for complex fracture models. Let's talk about phase field fracture concept. In phase field fracture modeling, cracks are not represented as sharp discontinuities. Instead, fracture is described using a continuous phase field variable that smoothly transitions from intact material to fully broken material. So, no explicit crack tracking is required and no remeshing is required. Indeed, crack initiation, propagation, and branching occur naturally. We will have a phase field variable start smoothly transited from 0 to 1 from intact material to fully fractured. This continuous transition helps us to not needing to remeshing rule. Formulation. Phase field fracture is formulated using an energy-based framework. The total energy of the system combines the elastic energy and fracture surface energy. So when we apply a force to a material, we will produce a strain energy into the material. This strain energy into material will produce some cracks. So we will have a new phases. These two energies, the fracture or surface energy and elastic energy, the minimization of these energies will help us to regularize the smooth transition. This regularization will be done by length scale parameter. So phase field cracks emerge by minimizing total energy, and length scale controls crack diffuseness. Solution strategy. We have a coupled problem here. The phase field fracture problem is naturally coupled, involving both the displacement field and phase field. In this work, a staggered solution strategy is adopted, where a mechanical equilibrium and phase field evolution are solved sequentially within each load increment. This approach improves numerical stability and robustness, particularly for problems involving crack initiation and propagation. So first we apply the load. In the UMAT subroutine, we solve the displacement field and update phase field. Abaqus will check convergence and go to the next load increment. This will again improve numerical stability and convergence. Abaqus model workflow. Model setup. First, we need a geometry and boundary condition. In this example, in this tutorial, we have this boundary condition. Mesh refinement near expected crack zone, and we will have a user-defined material UMAT subroutine to actually solve the equations. Analysis procedure. Incremental loading, we will have incremental loading, nonlinear solution, damage-driven stiffness degradation into the UMAT subroutine. Results. Crack initiation and propagation. Sequence of phase field contour plots. We have initial state, crack initiation in this image, crack propagation in the next image, and final fracture in the third image. Validation. Validation in phase field fracture is being done by force displacement curve. As you can see here, the modeling results at the right is in a good agreement with the experimental test results at the left, which confirms the correctness and robustness of the Abaqus implementation. Limitations. Typical difficulties of the Abaqus phase field fracture model. The first thing is limited documentation. If you search the internet, you cannot find many tutorials or manuals about Abaqus phase field fracture. So you have limited documentation. Complex Abaqus setup. You need to know where to use finer mesh and how to apply correct boundary condition. And the results will be sensitive to parameter selection, so you need to know well how to calibrate your parameters, and the mesh refinement requirements. Abaqus doesn't have built-in phase field model, so you need to write the equations and the model in the UMAT subroutine. With these limitations, how we can learn Abaqus phase field fracture modeling easily and quickly? We have two options for you. First, you can use our tutorial package, learn the complete workflow and apply it to your own project. Then, second, you can request a custom Abaqus phase field project. You can save your energy and time. We will complete your project. We will produce your desired results, and we will teach it to you by tutorial videos and online meetings. Let's have a look on our Abaqus phase field tutorial package. We have prepared a package including comprehensive tutorial videos explaining full theory and formulation. We have explained Abaqus model setup step by step. We have explained phase field UMAT explanation line by line, and also you will have result extraction and interpretation videos. We have also explained parameter selection guidelines, and we explained that the model is ready to adapt for your own problems. This package also includes complete Abaqus project files, all Abaqus files including .inp, .cae and other files. You will have also UMAT.for subroutine file, all documentation PDF files. The download link of this package is in description at the bottom of this video. If you want to order your own Abaqus phase field project, you need to provide your project details and we will provide a tutorial package of your project. So simply we receive details and actually details from you, and we will provide a tutorial package for your project with Abaqus model, user subroutine, tutorial videos, extracted results, and PDF and presentation training files. We will be with you until your full satisfaction. Thank you for watching this video. Contact us if you need any question.